Well, hey everybody, Mr. Reeves back with you today. And today we're going to be working on solving systems by elimination. And now we're going to be using multiplication before we add or subtract. All right, so let's go ahead and take a look at some problems where we're going to have to solve by using multiplication and then addition or subtraction. All right, actually, let me get back here. Where are those problems hiding? Here we go. Okay, so I'm on page 254 of your textbook in Module 8, if you are interested. So it says solve each system of equations by multiplication and adding. Remember, with the elimination method, our goal is to either add or subtract the equations together and eliminate a variable. You remember in the previous video, we talked about the fact that when you add opposites, you will always get 0. So 5 plus negative 5 is equal to 0. So 5x plus negative 5x would equal 0, and that would eliminate the x's, right? All right, also, if terms are the same, not opposites, you could subtract. 6 minus 6 is 0, right? So 6y, take away 6y, would also equal 0, and that would eliminate the y's. So when we have terms that are opposites, we add. When we have terms that are the same, we subtract, and that will eliminate one of the variables for us. But when you take a look at number 4 here, you have 5x and 3x. Those are neither the same nor opposites. And you have 2y and you have 6y, and those are neither the same nor opposites. So what to do? Does that mean we can't use elimination? No, that means we just need to work to create a pair that is either the same or is the opposite. Now they've asked us to add, which means we want to look for opposites. Actually, let me be consistent. I did opposites in blue up here. So we're going to want a pair of opposites. All right. Okay. So when I take a look right here, I know that I can find something that 5 and 3 both go into to make them opposites. But right here, what do I have? I have 2 actually goes into 6, or another way to say that is 6 is a multiple of 2. So if I take 2 and I multiply it by negative 3, I'm going to get negative 6. So I'm going to create the opposite of 6 by multiplying by negative 3. So here we go. So I'm going to take this top equation, and remember, we have to multiply the entire equation. Whatever you do to one side of an equation, you have to do the other side. And when you're multiplying or dividing, you have to do it by every single term. So I'm going to multiply that negative 3 by that term, and by that right there. So here we go. So negative 3 times 5x is going to give me negative 15x, plus negative 3 times 2 is going to give me negative 6y, and negative 3 times negative 10 is going to give me positive 30. So I've created a new equation. Now the great thing is all the solutions are the same. I haven't changed the solutions. But now what do I have? Right here and right here, I have a positive 6y and I have a negative 6y. And I can then add those together. So I'm adding these two equations together now, and I get positive 3x plus negative 15x is going to give me negative 12x. What's going to happen to these two? They're opposite, so they're going to cancel, right? And then here I'm going to have 66 plus 30, which is 96, right? And then I'm going to divide now, because when I did this method, and this is the great thing about the elimination method, you go from 2 equations with 2 variables. I hope you remember this from the previous video. 2 equations with 2 variables, and when we're done, we have 1 equation with 1 variable, right? So then we divide both of those by negative 12, and we get x is equal to a positive divided by a negative is going to be a negative, and 12 times 8 is 96. If you didn't know that, you could have used your calculator. So remember though, that's only half of our answer. We are looking for the ordered pair x, y that makes both equations true. And all we have is x. So now we need to find y. What is that y value? So we need to go back to one of our original equations and we need to find out what y is. Now, it would be great if we had an equation that said y equals, right? If we had one like that was in slope-intercept form. But if you look at these three equations, they're all in standard form. So we're just going to pick one of them. I'm going to just go ahead and pick this first one. Actually, I'll pick the second one. So I'm going to go with that second equation. My second equation is 3x plus 6y equals 66. And again, you could use this equation to plug in x and find y. You could use this equation to plug in x and find y. And you could even use that blue equation that I created by multiplying by -3, because the solution will make all of them true. All right, so then I'm going to go 3 times, but instead of x, I'm going to put -8, because that's the x value we found that makes both equations true. All right, so here we go. 3 times -8 is -24. -24 plus 6y is 66, right? So I'm going to solve this equation by using inverse operations. I add 24 to both sides. When I add 24 to 66, I get 90. And then when I divide by 6, 6 goes into 90 15 times. So y is equal to 15. So now I could go over here and I could replace y with 15. So what am I saying? I'm saying that when x is -8 and y is 15, I will make both of these equations true. I just checked it, or actually I just solved it by using this second equation, right? I could go back and check it in this first equation just to make sure that I am correct. And here we go. So I'm going to go to that first equation, 5x plus 2y equals -10, because that's what good math students do. They check their work when they can. So I'm going to go 5 times, but what are we saying x is? We're saying x is -8 plus 2 times, and what are we saying y is? We're saying y is 15. And what is that supposed to equal if we're correct? -10. Well, 5 times -8 is -40. 2 times 15 is +30. And guys, what do you get when you add 40 negatives to 30 positives? You get 10 negatives. It worked. So, going back to what I did, I wanted to solve by elimination, and they told me to use addition. So I was looking for a pair of opposites, because remember, opposites add to 0. I didn't have opposites, so I decided to create this pair of opposites. So I multiplied that top equation by -3. That gave me -6, where I used to have +2. That gave me the opposites I needed. So when I added the equations together, the y's were eliminated. I got x, and then I used that x to find y, and when I was done, I checked it in the other equation. All right? Okay, I hope that makes sense. So I'm going to clear all this out now, and let's go ahead and take a look at this next problem right here. Again, if I'm going to add these together, I want opposites. 4 and 3 are not opposites. 2 and -1 are not opposites. Now, a plus and a minus, those are opposites, but I need to be able to add and get 0. Well, I hope you can see that if I simply multiply this bottom equation by 2, right, what's going to happen right here? A +2 times a -1 is going to give me a -2, and then I'll have a pair of opposites, right? So I'm going to take this 2, and again, don't forget you have to multiply it by everything, right? So here we go. So that new equation on the bottom is going to become 6x minus 2y equals -16. This is the one, I got to be honest, students forget this one the most. They often multiply these two, but forget that one. Multiply everything. It's going to be 3 times every time. So positive 6x minus 2y equals -16. All right, and then I'm going to go ahead and rewrite that top equation, because I like to have them right next to each other. I don't like having that space between them. Okay, so here is my system, and now I'm going to add these together Okay, and when I do that, 6x plus 4x is 10x. What did I do right here? I made a pair of opposites, so they cancel. So this elimination method is going to work, right? So I get 10x is equal to negative 10. And then when I divide by 10, I get x is negative 1. All right, so what have I found? I have found the x value that makes both these equations true, but I still don't know the y value. All right, so when I want to know the y value, I go back to one of my equations. I can use either two of my original equations, or I can use the new equation that I created. I recommend you start with one of your original ones. All right, so I'm just going to go back up here to that equation right there. So I'm going to write it down. 4x plus 2y is equal to 6. But what do I now know about x? I know that for the solution, x is negative 1. So I'm going to put negative 1 in for that x so I can find out what y is. All right, here we go. 4 times negative 1 is negative 4 plus 2y is 6. I'm going to add that 4 to both sides. I'm going to get 2y is equal to 10. And I hope you know that when you divide both sides by 2, you get y equals 5. So what is my answer? My answer is negative 1, positive 5. Negative 1, positive 5 is the value of x and y that's going to make both of these equations true. Now, I use the first equation to find the answer, so you know by now what I'm going to do with that second equation. That's right, I'm going to check my answer. 3x minus y equals negative 8. So I'm going to go right here, and what are we saying the solution is? X is negative 1 and y is 5. So 3 times negative 1 minus 5, and I'm saying that better give me an answer of negative 8. Well, 3 times negative 1 is negative 3. Negative 3 take away 5. Guess what you get, ladies and gentlemen? You get negative 8. So once again, I wanted to solve this by elimination with multiplication and addition. I did not have a pair of opposites, so I multiplied that bottom equation by 2. That gave me this pair of opposites right here, negative 2y or minus 2y and plus 2y. So when I added them together, the y's were eliminated. I found an x. I plugged x into the top equation, found y, and then I used the bottom equation to check it. Okay, so that is solving the system by elimination, but it required us to multiply first. All right, so now if we go over a couple pages, this is where I was before. All right, this one says to do it by multiplication and subtraction, right? All right, so with subtraction, remember we want the terms not to be opposites. We want them to be we want them to be the same, right? We want them to be the same. So again, 3x and 6x are not the same. Negative 7y and negative 9y are not the same. But I know that if I multiply 3 times 2, what happens? What is 2 times 3x? It's 6x, right? So then what do I get? I get 6x again. Remember that 2 gets multiplied by everything. 6x minus 14y equals 4, right? And then I'm going to go ahead and put these equations together. But, oh, look at that. I'm not going to add. I'm going to what? I'm going to subtract. Because they're not opposites, they are the same. Now remember, again, from the previous video, if you watch my video, when you're doing the subtraction method of elimination, you want to make sure that you put those parentheses so you remember to subtract everything. All right, so here we go. 6x minus 6x. This is why we did it, right? 6x minus 6x is 0. That eliminates the x's. All right, so this is going to be a little tricky. And remember I suggested in my previous video, if you're not so good with integers, that you use a calculator. All right, so I'm going to recommend that you have that calculator handy, especially for these subtraction problems. All right, so here we go. We're going to go, oh, I can't see what my problem was. All right, come on, bugger, get out of the way. There we go. All right, so I have a negative 9, right? So I have a minus 9 or negative 9 right there. Negative 9 minus, right? Negative 9 minus negative 14. All right, now I'm using that term negative loosely because technically these are subtractions, not negatives. But the great thing is it works just like a negative, okay? So just so you know, I know what I'm doing. This is actually a subtraction of y, not a negative y. But you could treat it because these are now 0, right? 0 take away 9 is negative 9. All right, so we have negative 9 minus a negative 14. And when I do that, I get 5, positive 5. So please, 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 please be careful with your subtraction. All right, so 5y, and then I have 9 minus 4. Well, I hope you don't use a calculator for 9 minus 4. 9 minus 4 is 5, and then I'm really excited because I know I can divide both of those by 5, and I get y is equal to 1. Okay, so what have I just found out? I have found out that y is 1. I know the y solution, but the question is, what is the x value, right? We know what y is, but we need to know what x is. Okay, so just like with the previous problems, this part's the same. I'm going to go back to one of my two original equations. Even though I could use my new one, I usually go with one of the original ones. All right, I'm just going to go up with that top equation here, and I'm going to write 3x minus 7y equals 2. Right, but now what do I know? Now I know y is 1. So I go 3x minus 7, but instead of y, I put 1. All right, so that gives me 3x minus 7 equals 2. Now I have a two-step equation. I'm going to add 7 to both sides. I get 3x equals 9. Dividing by 3x is 3. So what do I know now? I can erase my question mark over here. And what can I put? I can put 3, 1. Whoops, I wanted to make that blue. What happened? Blue. Here we go. 3, 1 is the answer that makes both equations true, and I can prove it because I used the first equation, but if I go to the second equation, 6x minus 9y equals 9, and I put in my value of x, which is 3, and I put in my value of y, which is 1, I better get an answer of 9, right? Well, 6 times 3 is 18, 9 times 1 is 9, and guess what 18 minus 9 is? It is 9. So I have solved and proved that my answer of 3, 1 is the solution because it makes both equations true. All right, so I'm going to not go through and solve anymore right here, but I just wanted to quickly say, okay, what would we set this up if we were going to do subtraction? All right, probably I'd want to multiply this top equation by 3, right? And then that would give me, because remember, you have to distribute it through everything, that would give me negative 9x plus 3y equaled 33, and then I could subtract, right? And what would happen? These ones would cancel. All right, on this one, by the way, many times you have choices, right? Not many times, every time you have choices. So how do I decide whether I'm going to eliminate the x and the y? Well, you go for the one that is easiest to you. Now I look at this one, I go, oh, well, 1 goes into 2. I could multiply this by 2. In fact, if I were going to use the addition method instead of subtraction, I probably would multiply this top equation by 2. In fact, I'm not going to say probably. That's what I would do for sure. All right, but since they said subtraction, if I'm going to do it their way, because I'm a good obedient child, all right, I'm going to multiply this bottom one by 3, right? Because if I multiply this bottom equation by 3, I'm going to get 9x minus 6y equals negative 33. And then what would I have right here? I'd have a positive 9x and a positive 9x that when I subtracted, remember we're doing subtraction here, right? When I subtracted, they would cancel. Okay, so that's how you do the elimination method with multiplication and addition or subtraction. All right, now I want to skip over to the exercises. All right, and I'm going to tell you that since you have a choice whether you add or subtract and you have to multiply. Now, both methods work. I showed you both methods. My recommendation, ladies and gentlemen, is to always use addition. Always create a pair of opposites. And why would Mr. Reeves, your math teacher, recommend that you always use addition? Because I've been teaching a long time, and students make a lot of mistakes when they subtract. They just make a lot of mistakes. That one problem, remember, we had to do like -9 minus -11 or whatever it was, 16. Students make a lot of mistakes with subtraction, and they make less mistakes with addition. So my recommendation to you, since you have to decide anyway, is go for the addition method and always create a pair of opposites. Go for the addition method and always create a pair of opposites. So I just want to model that for you here. Again, I'm not going to be solving all these problems, but I am looking to create a pair of opposites. And again, I'm going to look for the easiest possible one. Okay, so what do I have here? I have 1x and I have 2x and I have 4 and 5. Well, 5 is not a multiple of 4, but 2 is a multiple of 1. So what I would say is I'm going to take this top equation and I'm going to multiply it by what? -2. And when I do that, what do I get? -2x minus 8y equals -4. Because remember, you have to distribute it through everything. And when you do that, what do you have right here? A pair of opposites. All right, so again, right here, I'm looking to create a pair of opposites. Okay, well, 2 and 3 are not multiples of each other, but 3 is a multiple of 1, and I'm looking to create a pair of opposites. So what would I multiply this top equation by to get the opposite of 3? That's right, I would multiply by -3. So that would give me -9x, right, minus 3y equals +3. What do I have right here? A pair of opposites. By the way, when we're doing opposites, we would add. When we're creating opposites, we add. All right. Well, hey, this one right here, 6 is a multiple of 2, and 8 is a multiple of 4. And look what I already have here. I already have a negative and a positive. So in this case, I would say, okay, I'm going to multiply this bottom equation by 2, right? And when I do that, I'm going to multiply everything by 2. You know what? I'm going to write it above it right here. 2 times 6x is going to be 12x. 2 times minus 4y is going to be minus 8y. And 2 times 14 is going to be 28. And what do I have right here? There are my opposites that will cancel when I add. All right, so do you see how that works? That we can create a pair that's the same and subtract, but I recommend look for those opposites. On this one, I would multiply this by 2 and get -2 and have my opposites. On this one, I would multiply this bottom one probably by -3, and then I'd have my opposites. On this one, I would just multiply this top one by 2, and then I would have my opposites. All right, so we didn't have any examples here where you actually had to multiply both equations, and I don't know if you're going to come across any of those. Maybe I'll look for an example of one of those and put that in my next video. All right, thanks for watching, everybody. I sure hope this helped, and I hope you all have an awesome day.